Guess I'll start. Mm. So, before I say anything, oh, no, not class. Has everyone been watching the videos? Has anyone been watching the videos? Testing. Okay, assume that everybody has watched the videos. I can't. I'm not sure though. Anyways, so I think Crumbly and requested me to go over the second merchant. That's the final thing. Yeah. After this, you have all of the material possible on test. That's all covered in these reviews. And yes, tomorrow is my last day of class. How many bytes are used in code and ASCII character? That is 8. Imagine using lots of data. Imagine using lots of data. Compression allows for original data to be constructed without loss of information. True or false? That's false. Your kind. With a 14 points exponent is encoded in which binary format? This is K. 27, so that's 27 is a K. There you go. Convert the following UTF-8 encoded binary into a Unicode character. So we have 3. So what you do is you start from the left and go to. So you start from the right, go to the left, and you read every 4 numbers. Okay. So the first one is 1010, so it's A, right? And then you have 3 zeros. Sorry, 2 zeros, right? And you ignore this 10. Okay, ignore this 10, and you take the rest of it. So you have an 8. So it's B, C, or D, right? And now you're up to here, 1001. 1001 is 9. So this is a 9, and then and then you know this part. Then you read this, right? 0, 100, which is 4. So that's B. 3 this way, and number 2 separate from each 4 numbers. Which statements are regarding access K? So when positive, it has the same binary code as 1's complement. That's not true. 2 percentage is 0, that's not true. 1 percentage is 0. Has a sign bit. That is not true either. B, C, D positive items are represented by what bit pattern? So this is we're looking for C. C is 13. So 101. So that's C. And then this one is a 4-digit. So you convert hexadecimal to binary. This first one is 0011. The second one is 1011. Yeah. The third one is 0010. The fourth one is 1010. So let's see. 1011. Oops. 0011. Yeah. 1011 here. 10101010. Okay, that's wrong. 0011 1011 0010 and 1010. Yeah. Now, perform subtraction operation to the following 2's complement numbers. If the result is wrong due to overflow, please indicate. So 1. So here is the answer, that's why. So if you convert this to back to decimal, right? This is negative 0. So 100 minus 1. Sorry, plus 1, I should say. Yeah, minus 1 is 3. So next 3. Welcome. 1010. So we have negative 1, 0, 1 minus 1 equals to 4. That is square negative 7. So that is wrong. So this is why the answer is overflow. So this is
Okay, can you go over why it was overflow for the last one?
Because if you check it right, if we check it, it's incorrect. And also there's one bit was dropped. If this answer was correct, then it's overflow. Also because no, two negatives just never makes positive. Was that clear?
Yes, thank you.
Okay. So number 9, what volume is encoded in the following single precision floating point? So this one's is a special case. If you go to the top part. Okay. So it's wrong. We don't. Let's see those. Oh yeah. So we have 1, right? And we also have you also have period. Yeah. So I also have 3 ones here. So this is not a normal number. Not a number. So a 13-bit floating point start more violence than a 13-bit integer. If you go to the float, excuse me for 1 second. Okay. Hope, hopefully, no, yeah. Hopefully that will limit the noise for a bit. Anyways, so as you can see, today's time for is 16. Uh, uh, hold on. Got so here. Floating point, right, is higher than integers in bit number. I think it's earlier. Might be earlier.
Hugh, how are you? Can you show the question again? Is that okay?
Yeah. So yeah. No. Here. Question number 10. A bit floating point integer. Alright. If so, a bit floating point can store more values than a 32-bit integer. True or false? If you go to think the first lesson he talks about this, but before I can Google it too. Because look, if you oh no, it's easier to Google this, right? The largest integer you can produce is this number, right? If you go to float, is even larger. So this is why it's true. Return to floating bit points when it can support a 24-bit on the number. We had a lot of debate about this last time. Because like a lot of people were saying this was false. But if we go to an odd volume, right? What?
I mean, isn't it 24-bit included? I mean, it's a smaller number than 24.
Yeah. I say it's a small number. Also the largest odd number. The largest odd integer is probably smaller than this number.
Yeah, I think so.
Yeah. So that's why it's true. Mm. If we go to the 12th question, so what volume? Not volume. The volume in the what would be the volume in decimal of 2's complement encoding was used. So you ask me how you do this. First, right? Isn't this one here? That in case is negative. So right away you can, and then like this one and this one, right? And then you focus on the last few. Okay, like focus on last few. Because these all turn to zeros, right? So this also turns zeros. This one is 1, 1, 1, 1, 1 minus 1. So it's negative 0. This is no. Oh wait. Oh yeah. Oh no. Yeah, you're right. You're right. So yeah, if you're adding one to this, then it's that's 32. Right. You're adding one. You're right. I forgot. But still, it's yeah. If you add a 1, this is a 5. This is a 6. But still negative 11. That's still wrong. So now you have this thing. So in theory, if the leading byte looks like this, right? How many bytes are encoded are used to encode a character? So this is if you split the first two, right? It's 2 because there's more than one. So yeah, there's no such thing as 8. That's 8 is UTF-32. statement about three statements are true about 2's complement encoding. So 2's complement, there's of course a sign bit. There's one representation of 0 because you add 1 to it, so you say move the 0 up 1. This is why you don't have negative 0. Yeah. And then for this one, for positive values, the binary code is identical to 1's complement. Since if you want to go, I think the answer is also an answer. If you go to, and just check though. So here, yeah. See wait, no, not here, not here. Here, you see 3 and 3, 2 and 2, 1 and 1. They're all the same. So that's also an answer. And that's it. So convert the following on-site binary to on-site binary, okay, to hexadecimal. So 1, 2, 3, 4. Whoops. I guess that's close enough. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Okay. So the first one is 3. The second one is 7. It doesn't matter what order you do, okay? This was way reflexible. So this one is wait a minute. Oh. 1, 2, 3, 4. What? How is this? No, E doesn't exist though.
It does apparently.
Oh wait, it does. Right. C, E, and yeah, you're right. Whoops. I mean, there wasn't F, yeah. So if it goes beyond F, it doesn't exist. If you convert from decimal fraction to binary, so this is 0.5 plus 0.125. Yes, I memorized it. Not ask me how. We have 0 to the negative 1, and we have a yeah, the negative 1 is 0 after it, and then we have a 0 because this is 0.25. So that's D. This is binary, not BCD. Okay, it's binary. So if we go to 17, convert the binary decimal. So we have the first one, so 2 here, and this one is 4. 1, 2. So this is 4. This is 8. This is 16. 16 and it's 32. 32. We have 2 to the 6, right? This is 2 to the 7th. So 2 to the 7th. plus 216 plus 4 plus 2 equals to 1 inverse. You guys yell too loudly. You guys yell too loudly.
你那个叫什么鱼还吃吗？
不要啊。27 is 128 plus 16 plus 4 plus
$1.50.
2. Yes, this is a muffin. 150. So, how many M bits are used to encode an ASCII character? Bits. Okay, bits. The other one was, I think, if you go all the way up to bytes. So sorry. Whoops, I misread. So this thing is wrong. If you let me waste a second. See, because it's bytes. If you go back here to where is it? 18. So bits is 8. 19. What is the range of decimal values that can be used to represent by 8 bits using sign magnitude? So you remember about about this last time? Wait, sign magnitude. I feel like that would just be C, wouldn't it? I mean, no. Oh, yeah, B. Because this one, it has 0 right in front of it. This is first digit is 1. So it's a negative number. Here you go. This one, I think Kenny went over this when we were going, went over the other way of doing it, right? When we were going over the final. If you want, you can just reference the video. It's the answer 48. If you want to this, so what? How's A?
Standard code. Excuse me. What's it telling me? Yeah, sign magnitude can be the same as one complement.
Yeah,
Have two zeros
yeah.
plus minus. So that's
Oh yeah, you're right. Yeah. Okay. So yeah, if you it has 2 zeros. That's why. If it doesn't have 2 zeros, then
yeah. It's the sign magnitude.
yeah,
Minus.
yeah. Because this rotation and positive 0.
I
Eh,
think you. I'm
huh?
sorry to interrupt, but I think you had it right. I think it's B.
What?
I think it's B, not A.
So what were you trying to say?
Or no, no. You know what? Leave it like that. No, no. I'm wrong. I'm looking at the wrong thing. I'm sorry.
Okay. So this one you can go over I think yesterday's video to do it the other way, which is counting the each number in hexadecimal number, which results into 12 numbers, and then you times by 4, which is converting hexadecimal into binary. Anyway, there are two representations of 0 in one's complement. Okay, one's complement. That is true. Convert the following unsigned binary to decimal. So this one's B. Because we already did it the other way around. A and the following 2's complement numbers. 2's complement. Okay. If the answer is incorrect, do the overflow piece in K. So this is an addition problem, so let's do it normally. That's a 0, sorry. 1, 0, ooh, 0, 1 here, 1, 1. We'll drop this one. So this one is a this one's a negative number as well. So the 1, 0, 1, 0 plus 1. So 1, 1, so that is 7. Right. This number is negative 7. So if you do this, 1, 1, 0, 1 is that's negative. This one is let's see, 1, 0, 1. So it's 0, 0, 1, 0 plus 1. So that is 3. This one is 0, 1, 1 plus 1, which is 4. That is negative 7. So this one is correct. So you get B. Perform the following multiplication operation on the following 2's complement numbers. If the result and the answer, so if the result the answer is wrong, do the overflow. Basically, so we're gonna do this cleaner the last time because I buggered it up last time. 1, 1, 0, 1, 1, 1, 0, 1. So this one is 0, 0, 0, 0, and then we have 1, 1, 0, and then 1. Okay. So I'm going to point to my answer since we have our space in there. This one is going to pull it down to 1. This one 0, 1. So that's 0. There's a 1 here. So that's a 1. And then we have a 1 here. This one is also a 1. We get 1 here and 1. And this one just adds up. So here's the answer. Right. If we convert this, sorry. So this is a 4-bit integer. is a 4-bit integer. Your answer can contain up to 8 bits. Right. Now 1, 2, 3, 4, 5, 6, 7. You're just under 8, so that is fine. Which are fine and encoding this is a sign bit. So this is what?
Here, here, I'm sorry to interrupt you. So you use overflow when it goes over 3 bits?
Yes, because this is a multiple one. This is a multiplication one. Yeah,
Gotcha. Thank you.
it doubles the number of bits you have removable. Anyways, B, um, this is C, this is D. There are two representations of 0 in 2's complement. Okay, in 2's complement, this is false. Given a 32-bit single precision point, what is the smallest positive volume that can be represented? The smallest positive volume in normalized form. So there was a slide about this, huh? And yeah, I have also slides. I don't know why it's also slides. If you go to yeah, there's also a slide for if anybody has one more doubts about my I guess my multiplication thing. If you go to the day he did multiplication, I think it was the day before this one. Yes, the day after the day before. Oh god. Yeah, day after. So if you go all the way down to barring exercises multiplication, right? Multiplication. Look, input is 4. The output size is essentially 8 bits. There you go. So go back. If you go to am I counted correctly? Sorry, we can go all the way down to oh wait, we're already here. Okay, never mind. So now we go to the 14-point day, which is I think the 12th. Yeah, 12th. Okay. So stop yelling. Please stop yelling. Uh, the smallest possible. I think it says it somewhere here, huh?
I think you got it. I think it was on where it says single point precision.
Yeah.
Wait a minute. No, wait a minute. I think it's okay. Right. Where it says yeah, it says 127. I think it's C. Or is it 24? Because that's the only one that we have listed for 27, basically.
Yeah.
Just make sure. Don't go there. I'm not doing one of these class.
Uh, if you let's see, where is it? Yeah, it says this 127. Oh here. Wait, no. No, this is an example. What? unless according to last time. Where's last time? No, if you go, I'm going to look. I'm going to look. Oh, smart positive. Okay, so let's see. Yeah. So C is the same. Yeah. So let's see again. If what is the range values that can be represented by 8 bits using 2's complement? So remember, this is 2's complement, which makes it different from the first question. So you have one representation of 0, right? So you're not eliminating the other representation of 0. So your answer will be D. Because you're only minusing one from this part. From one part.
Question, why would you be minusing the 1 from the positives? Wouldn't it be radical times 2's complement?
Oh yeah, you're right. Hmm.
The one off where there's 0.
Yeah. Yeah.
Oh,
Yeah. Yeah.
I
There
get
you
it.
go.
Yeah,
There you
yeah.
go.
Because from 0 to 2 so
Yeah.
that's it.
Yeah.
Okay.
So this is binary code. Hmm? No, it's not. What?
No, 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 go ahead. I'm sorry.
Okay. If you 29. What is the binary code decimal for 6.5? So it is not C, it is not A, it is not D because they all have decimal points. It's A. It means B. Sorry. Okay. A binary code decimal does not have decimal point. There's no decimal point. Uh, anyways, which is the largest volume that can be stored in a normalized 32-bit floating point? That is one special cases. If you go to the chart, you will see plus infinity. So yeah. If you yes we are. So BCD, we are not using internet. You just can't cheat. And you just can't do it together. BCD, so whole team point to parse one to numbers. True. It's a parse them, but it does not include a dot. Okay. So here you go. In a double precision floating point encoding, what decimal exponent is represented by this? So it's double precision. So it's not A or B. And since there's a 1 here, is D. So now we're going to see which is not valid for UTF-8. So this one's valid because there's 3 and there's hold on. Whoops. There's 1, 2, 3, but there's an extra one. So this one is not valid. C is also not valid because the first thing is 0 and nobody no. D is valid. Hold on. If you go, let's see if it's an asking number, then it should be correct. It should not be then it shall be valid. If you go to the 14th and you go to yeah yeah okay. So the first D I'm wrong. So if you go to here, this one, and then it's an ASCII number. So erase this. So yeah, this is ASCII. This is a 2, and this has 3, but this one there's a 4 trillion bits. This is why it's wrong. So what is the volume, right? In encoded of single precision floating point was used, right? So now, this you have the exponent here. If we go to 127, and this is converting the binary as 1, 2, 4. This is 8. This is 16. This is 32. That's 64. So 60.
Where's the highlighted part? The blue part for the exponent.
Yeah, no. Wait, what? Oh, yeah, you're right, right. Yeah, so this part is the exponent. Whoops. So, this one is, yeah, and this is a decimal. And since here's a 1, this is the, negative. So, you have a 1 here. This is, 1 plus, 1, 1, 2, 3, 4, 5, 6, 7.
You're getting the eighth zero.
Oh, okay. So yeah, never mind. So yeah, this is a 2. Sorry, this is a 2. 2. One. Oh, sorry. 1, 2, 3, 4, 5, 6, 7, 8. So 128 plus 2 is ignore this is 64. We have 130. 130 minus 127 is equal to positive 3. Okay, so we have positive 3. Uh, okay, so now we're gonna convert this into binary. So negative. This is 好了吧，冲好了，冲好了，你不要老是放在上面。这这冲好吗？ This is a 5, and then you have a 1 0.1. So right, you have here's number 1. 1 is sorry. 1 is 1.6. Oh, that's 6 to 5. Right. If you do, you're moving your thing. 嗯 Oh, remember. Right, move it from here to here to here. So, the closest answer is
No, hey,
wait, what?
what we did was it
Huh?
so times 2 to the third, then you move
Yeah, 2 3.
decimal to decimal by 3, and that would be your binary.
So 1101 is 13. Oh yeah, you do it first and then cover it. That's what it is. So I think if you go this question, where is it? Here. So this one is C. Okay, it's not A. It's C. If I cross this one, ignore this. Okay, this is C. So now we are fine. If you go back to this one, this is one's complement. So this should be the same idea as sine. So it's D. 36. If you convert into decimal to I think this one is C. Yeah, this is a simple conversion. And then you have 38 is this is we found out it's fixed width, so that's true. We looked it up. If we go to 38, convert the following unsigned byte to octal. So you just count 1, 2, 3. The first one is a 1, 1, 2, 3. The first one to 0. Second one to 0. 1, 2, 3. And that's 2. And 100 is 4. So let's see. 39. This one is it's all 0, so it's 0. This one, so optimal. I think I suggested you to do this. If you convert this, right, this into a what binary, then convert this into this, you will get the fastest answer. So 3 is 0, 1, 1. 7 is 1, 1, 1. 2 is 0, 1, 0. 3 is 0, 1, 1. So now we have 0, 1, 1, 1. Yeah. So the first one is 7. And 1, 1, 1, 1, 0, 1. And there you go. Okay. So our last one is 3. And this number is D. So that's C. We're going to save this one. Okay, so if you exit and leave. So what we're going to do is we're going to save this into a new document. Save. So this and what we to do is we put save as and put a 1 after it. Okay, so you guys don't get confused. And then we have classes have ended. Okay, and there's no class, it's just the final. If you want to take the final say, which I'm pretty sure only one person did. Does anyone know? Does anyone know if anyone took the final? Does anyone know?
Not
I mean, why don't you?
necessarily anyone did, but I was going to ask like did you take it?
Yeah, did.
Yeah, I decided to go first, to be honest.
Okay.
But I know you said that you were gonna look for the modified paper's final.
Yeah. But it didn't have an emergency, right?
Yeah, no,
Okay.
it didn't have an emergency, but
Okay, that's good. That's good.
because I originally would have taken it instead.
Okay. So yeah. So everybody is taking the same version. So we don't know the other. We don't know what the other test was. Anyways, if you go back to we're gonna go over the last thing because I am still fine with doing this. If you go to downloads and go to this one. So this one is a repeat of, well, it's not a repeat. It's just the same questions in different order. You see, one comes with first, right? Two representation zero, that is true. We draw a line. Which one's comment? This is yeah. This one's overflow. But if you want to if you want me to go over this again, you can ask. Let's see. This one is negative 32. This one is 14. So 14 is. This is 15. Right? This is 14. This one is C, not A, C. Because there's a 1 at the end. If there was no 1 at the end, then the person is correct. This, there's two resolution to comment. This one, the person is correct. This is false. This, or right over this. This is not E. Okay, it's not E. It's the other one. It's D. And this one, remember this, that's correct. If you go here, this one is not a number, that is correct. This is 1, 2, 3, 4. That is 4. This is 128. Because no, it's events. This is which one's represented? Sorry, in BCD, negative value is represented by one volume. So this is C. This is D. So that's correct. This is negative value. It's not positive. And here is the largest value. Largest value is D, not C. If you see a cross or any like lines through the answer, that answer is wrong. Okay. This two's complement is correct. So we're gonna highlight it to emphasize that it's correct. This one is we already know last time. It's true. 16 is the he is correct again, or she, I don't know. This is false, correct again. 18 is A, correct again. 19 is three. B 10 10. Oh. Oh no. Beating this. No. Yeah, okay. So this one is D. Sorry, I wanted to make sure. And 20 is C. And this was
Sorry, I'm sorry.
what?
What do you have for 19?
19? Uh, let's go back to 19. D. D. Are do you want me to go over it again, or are you okay?
No.
Okay. So 20 is C. 21 is A. We have went over this. If okay, pause me if you want to go over any question again. Okay. Anyways, B. B is A. Not B. A. So we're gonna cross this out because you automatically dropped the last one because it's now over 4 numbers. Anyways, how many bits are used to encode an ASCII character? That is wrong. This is the correct answer is B, 8. Because you have to remember that the extra bit includes extra characters. Anyways, this is correct. So that's B. This is C. That is correct. This is, let's see, true. So this is 5 bits. There's, yeah, this one's correct. Let's go highlight all the answers. Okay, remember this is a multiple answer question. If you don't fill in these 3 answers, you don't get points. You have to fill in all 3. And this one is true. This one, 28, is the same thing as sign. So we have, oh whoops, we have D. I think your mic is a bit loud. Yeah, well your mics are a bit loud. Anyways, unity of A is fixed lengths. So this one is true. This one is so 2 byte number that is true. It supports it, but there's no decimal point. I'm gonna just re-emphasize it. So this one, I think we numbered this last time, and that is correct. And this one, it's two's complement. Time magnitude and one's complement. Same thing as the other one. Okay, for all 3. If you don't do all 3, no credit. This one is remember this last time is A. This one, that's D. Remember this last time. This is an A. Yeah, almost, yeah, I'm pretty sure all the questions are repeats. It's just in different order. This one, so we sent that, yeah, sent song. Oh, 1011 00. So this one, the number is different. This is why you need to be careful. Since the number is different, this is 1010 and tell them, okay, this is B, okay? Did not get confused. This number is different from the other number. That is why this is A. If you go to here, binary to octal, I think, yeah, this is also different from the other test. 1100, 110, 101, and 101. So mm-hmm. 1000. So 10 is hmm. Hold on. Oops, I think I did this wrong. Okay, so as you can see, there is what you call an odd number of them. Yeah, you have to do it the other way. If it's even, you can do both ways. And sorry, an odd number of binary numbers. So you have to do it this way. And then you have this. And then you have that. So this is a 5. This is 1, and that's 1. So that's C. So and here you just pad it with zeros. Yeah, that's what you pad it with zeros. Which probably is correct. So D is correct, right? But they're missing one. Wait. Oh, it's only D. It's only D. Okay. Because this, depending on how big the K is, it might be different. This is bytes, not bits, bytes. So this is wrong. D. 40. So sign magnitude is the same thing as 1 commit, so that's C. Okay, we've all went over all the material that that we have available to us. So in an earlier post, right? If you go to here we go Discord, you go go to study material, right? This is all the blanks. Okay, it's all the blanks. There's nothing on it. You can do this for yourself if you want. You can look over your answers if you want. It doesn't matter. And now I'm going to post all of the answer sheets, answer keys, I should say. So, as of now, does anybody have any other questions? Going once?
Is the 4 months is mandatory?
Yes.
I don't know if we have to go to school.
Hmm? We do not have to go to school.
Everything is online, just like in
Yes.
Japan.
Yes. I think we have less questions than last time. Yeah. He said 30. So less questions than last time.
So is it 30 questions for 1 hour?
Yes. Yes. Okay.
Yes. Okay.
So by the way, tomorrow is going to be the last day of class. I will not be in the school after.
What did you say? Can you repeat again?
Okay. I said tomorrow's my last day of class.
Oh, congratulations.
Yeah. If I'll still be on Discord if you guys like need help and stuff, but yeah. And also, I might be also debating on doing master's degree. Not this year, maybe next year.
What? A master's degree?
Yeah, not. I'm gonna try to work first to like gain experience.
Understandable.
uh, or should I do both? I don't know. Both. I probably would do part time. Um, I guess I'll see. Yeah, I guess I'll see. I'm gonna take it. I'm pretty sure I'm gonna take a small break because it's yeah. I've heard that master's degrees are really hectic.
I mean, there's plenty of masters in medicine.
Yeah,
As much schooling as you want to.
yeah. Hmm. If you go to access, here you go. Is oh that's wrong. Whoops. You know what? Since my yeah, I'm gonna do that. I'm gonna ask my best friend what he felt for about his masters and then design because he just got finished. Anyways, yeah, I cannot do a master's for computer science. That requires more time. So this one, okay, and then because I need to, do let's see, I need to either look for a as an SHSI sorry CIT masters in nurse school, right? Or or complete my career science degree, right? And yeah, what? Yeah, yeah. For
So for
mm,
nurses, they take
mm,
4 masters
mm,
in different classes,
mm,
but only if you take those classes first.
oh,
You know what I'm saying?
oh. So I can do either one then.
Exactly.
Okay, okay.
But if you have a master's, you have to take
Bachelor's.
bachelor's.
Mm,
You know what I'm saying?
mm, mm. Yeah.
Because in my case was to like do a bachelor's degree in whatever,
Mm.
and do a master's. But
Mm.
because I was studying from Mississauga, I said,
Mm.
let me just go and do a bachelor's degree in computer science.
Yeah.
But if I were, let's say, younger and did something else, like let's say
Mm.
maybe have 2 years of expertise,
Yeah.
me myself, I would do just a master's degree instead.
Okay.
You get more opportunity.
Yeah. Yeah, that's true. Ah. Just me thinking of should I? I don't know.
Take your time.
Yeah. I don't know. I kind of want to take a break though. So everything's uploaded. If you, I'm gonna upload this video right after.
That's fine. Yeah.
Yeah, yeah. If you no, yeah, yeah.
Well, let me ask you this
Mm?
before we just hang up. Please.
It's fine.
Um, um, by any chance, are you guys gonna be free tomorrow before the test, or what do you say?
It's today's last one, unless anybody else have like any last minute questions.
For example, I downloaded a couple of Word files for the dance that we're
Yeah,
going right now.
yeah.
Is those two? I mean, I just took a look real quick.
Mm.
Those ones let me see. You got the 81 MB.
Yeah.
That has to do with the second part of the
Yes. 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 This is the second part. Okay. Yeah. Yeah. If you see an X number after it, that is our answers.
say it again. If I see what?
If I see, two 75042, right? If you see a two, that is my answer to it. If you see in AD 111, yeah, there's an extra one, yeah,
Right.
yeah. The reason I changed the file names is to just differentiate.
No, I got it.
Yeah,
What I'm gonna do is I'm gonna see if you might be able to be on Discord like in the afternoon.
yeah, 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 definitely.
I send you a message on Discord. Just maybe we can gather a couple of people, maybe review a little bit more.
Okay.
Although I mean, when I asked the question that I asked you before is going to be
Mhm.
the same way as we did the midterm.
Yes.
The midterm we had the window open.
Yes.
So you think it's going to be the same thing for the final?
Yes.
Okay. All right.
Yeah, it's all the same. And it's all the same as last time. You still need to have a camera.
Oh, for sure. Yeah, yeah.
Yeah,
I
yeah,
understand that. Yeah, yeah.
yeah,
It's just the fact that if
yeah.
you're gonna do something, it's like
Mm,
hey, what you doing?
mm.
And then I get screwed.
Okay. So yeah, if you have any questions, then just ask tomorrow. I will be in Discord
Yeah,
now. Yeah.
yeah, yeah. I'll hit you up on the Discord.
Okay. All
All
right.
right, man.
Bye.
Take it easy.
You too.
Bye, bye.
So bye. Let's see. What? Stop recording.